Hi, hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Malik, and here I will present to you about the recyclable material classification by using convolutional neural network. So, this is my group mate, Abdul Hakim bin Muhammad Zahari and Iskandar Naqiuddin. So, uh, for the introduction, as the number of the waste that have been produced required a different processing method to be disposed. So there are many methods available to be used as to dispose the as to be used as to dispose the waste product. So besides this type of waste cannot be managed at all secure manner. So that many methods have been invented to solve the problem. One of it is classification and identification the waste system in the image processing method as to dispose the waste product. And for the this relevant method is also can ensure the environment protection and with the conservation of energy. So on this task, we have used three methods, which is the first method is a convolution neural network (CNN). This method is widely known as the ConvNet and has a deep feed architecture as the network of entirely linked structure. So for the second method is the residual neural network 50, which is ResNet 50. This residual network is a neural just like the artificial nervous system ANN that can be recognized in the cerebral cortex from the pyramid cell. Furthermore, the ResNet 50 is a large network of the residual. For the third network, for the third method that have been used is the inception V3. This inception V3 is the neural network that can be support image recognition and the object detection beside can be start out as the GoogleNet module. This inception V3 is also a Google third version of the convolutionary network neural that was implemented in the ImageNet recognition challenge. So next I will give to the Iskandar to do the task 1.
Ya, Assalamualaikum Doktor. I am Iskandar Naqiuddin Muhammad Isham, DE 17015. So today I will present about the task 1, the how to train the model M1 and to get the model M1. Alright, I'm using the Google Colab to train the image of the data set. So with the Google Colab, we can upload our data set into the Google Drive. So from the Google Drive, we can call it from the Google Colab, and it will we can call the file to import into this program. As you can see here, this is the file that we put in the Google Drive, and we can call it to this Google Colab. Alright, and then for this program, we use the input TensorFlow for the library. So this training will train by the TensorFlow, right? And in the TensorFlow, it will do the neural network like convolution and max pooling. And then this is the architecture that we will show the process and the accuracy code, right? For the generating batches and for tensor image data, we use the sub batch size is 20, and this is for training generator. For validation generator, we use batch size 20, right? So to start this training, we need to import the matplotlib pipeline. Alright, so after that, we classify the name, can and pet, and this code is to show this picture, to show which one is the can and pet. As you can see here, it will show the right picture, right? Okay, so after we show, it's not necessary, but I just want to show to this program. Alright, then after the step, we scale the image to 1./255 and to train and to the test. Alright, for the train generator we use base size 20, and then the validation generator we use 10 for this data set, right? And then this is the epoch. So epoch we use the 10 step per epoch we use 10, and validation step is 10. So however, this is the data we get. The training loss is a bit low, as you can see here is many of the epoch is negative loss, and for the accuracy is high, we got 1. However, the validation loss is a bit higher than the training loss, and also to the validation accuracy is a bit low than the accuracy training. And then when we can see the graph with using this code, okay, after I run this code, so the output will show like this. And as you can see, the training accuracy is a bit high, but the validation accuracy is a fluctuate. Alright, and then this is the training loss. For the training loss is very low, but the training, the validation is fluctuate too. Right, so now we go to the test 1 to produce model M1. Alright, this we use the optimizer Adam, and this is the test that we use for the test 1. The file, right, the base size we use is 20, and to execute this, the epoch size we use 10, step per epoch is 10, and validation step is 10. Okay, as you can see, the loss is almost negative, and the accuracy is high, 0.3, but not achieved to the 1. Alright, so this is the to get the output for the graph. It's a bit nice because the accuracy is increasing, not going to decreasing. Okay, and then this is for test 2 file. Alright, and then also same, to execute we use the same step approach, epoch and validation step. Also loss we get is 0, something like -0, and then the accuracy is a bit higher. However, when we look at the output, it's fluctuate also. Alright, okay, this is what the last test is, the last test 3. Alright, we also use the same BH and same value for step epoch and validation step. Also same for the execute, we get, it's not the same, but the loss value and the accuracy is near like test 1 and test 2, right? So when we produce the output, the accuracy with the epoch is slightly volatile also. So this is for test 4. Alright, we gather the 3 picture in the one file. So when we also same, the batch size is 20, and the epoch step, validation step is 10. Alright, then this output, this execute, we produce the output, and this is the output, right? So thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Hakim bin Zahari. So I would like to present from our assignment 2, which is I completed my task 2, which is we need to choose either two training session, which is I choose ResNet and Inception training. So for the first thing, we need to import our Google Drive into this Google Colab, and then we get the key for activation, and then we need to assume where is we save the data in a Google Drive, which is I save in this my drive ICS and train. So we move to setting that I have made, which is on the setting I use is step per epoch I use 22, and epoch I use 10. So this is my result, which is my accuracy is nearly to 1.0. Almost all of them is accurate 1.0, which is all these 99, 99, 99, 90 something. So this is the graph accuracy that I get, which is this is the graph that we get from this data. So this is the loss graph that we get from the data, which is the loss is become decrease. So it's same thing on the ResNet, which is I use the same way, which is I import my Google Drive into this Google Colab, and the same way, and the setting epoch also same, which is step per epoch is 22 and epoch is 10. The accuracy is more accurate than Inception, which is we get 1.0 or about 1, 2, 3 and 4. For data I get 1.0, and others is 90 point something. So this is the accuracy that I get from the coding, and this is the loss data that I get from the loss graph that I get from the data. Thank you.
Okay, thank you, Abdul Hakim. So for the conclusion, based from the method that have been used, of three methods that have been used, Inception V3 achieved better performance. So among all the methods that have been used, Inception V3 achieved the best result with accuracy of 1.0 with the less losses. So this shows that the transferring Inception V3 model on the large scale natural image database could be the effective way as to build the deep neural network model for the classification image database. So, but however, in the term of storage, ResNet and Inception have a disadvantage as it consists a small memory, so that it may not suitable for any embedded device. So that's all from us. Thank you.